Hello. Today we'll be going over the El Hospital rule. So, what is the El Hospital rule? So, the El Hospital rule is when a limit has an answer of 0 over 0 or infinity over infinity. For example, the limit of x to 3 of x squared minus 9 over x minus 3, and the limit of x to infinity of 6x squared minus 2x over x squared plus 1. This one will give us 0 over 0, and this one will give us infinity over infinity. But as we've learned before, the limit of x to 3 of x squared minus 9 over x minus 3, we can solve this without the El Hospital. Based on the formula a squared minus b squared equals a plus b times a minus b, we can change this one right here to x plus 3 times x minus 3 over x minus 3. The limit of that. It's very important to remember your limit, because if you don't have it, the whole equation would not work. So when we cross this out and we get x plus 3, then we can plug the 3 into x. Therefore, 3 plus 3 equals 6, as you can see here. For the limit of x to infinity of 6x squared minus 2x over x squared plus 1, we can simply do limit of x to infinity of 6x squared minus 2x over x squared plus 1. We can just simply take out the x squared from both. So we would have limit of x to infinity of x squared over x squared times 6 minus 2 over x, and this one would times 1 plus 1 over x squared. So first we can cross these two off, then we can put in the infinity for x. Therefore, having 6 minus 2 over infinity and 1 plus 1 over infinity. And when a number is dividing by infinity, you would get 0. So we can reduce this down to 6 over 1, which is 6. Next, so when we have a limit like this one right here, the limit of x to 0 of sine x over x, we would get 0 over 0 in this case as well. And the limit of x to infinity of e to the power of x over x squared. This one we would get x infinity over infinity as well. But the real question is, how are we going to make it not that anymore? Which is why we applied the El Hospital rule. So, the El Hospital rule is if the limit of x to a is, f x to a of f of x over g of x is 0 over 0, or if the limit of x to a of f of x over g of x equals plus or minus or positive or negative infinity over positive or negative infinity, then we can have the limit of x to a of f of x over g of x. We can make it the limit x to a of f prime of x over g prime of x. So let's do an example. The limit of x to 0 of sine x over x. How would we do this? So we would first see if it equals either 0 over 0 or infinity over infinity, which this one in this case equals to 0 over 0. And there's no way we can substitute or do any other equations to solve it, like the x squared minus 9 over x minus 3. So we would have to use the L'Hospital rule. Limit of x to 0 of sine x over x would equals to limit x to 0 of sine x prime over x prime, which would give us cosine x over 1. And then now we plug in the limit of x to 0 of cosine x over 1. Yeah, never forget the limit. Like I said, this is super important. The cosine x over 1, now we have cosine of 0, which equals to 1. And now a more complex question. The limit of x to infinity of e to the power of x over x squared. So we would do the original steps. So this one equals to infinity over infinity, and we cannot use any other ways to solve it. So we would have limit of x to infinity of e to the power of x over x squared equals to the limit of x to infinity of e to the power of x prime over x squared prime. So this one up here, we got an answer down to a number right away. But in this case, we would get e to the power of x, or limit of x to infinity of e to the power of x over 2x. So we still have infinity over infinity. So we have to do it one more time, which is limit to the x to the infinity ex over 2x. We would have to prime it one more time, also known as double prime, since we already used prime up here to get, or no, we put prime again, and this is the second derivative right here, and we would get e to the power of x over 2. And when infinity is divided, and then now we plug in infinity. So when you plug in infinity, it would be e to the power of infinity, which is infinity, over 2. And when infinity is over a number that is like 2, then it will be infinity. But then if it's a negative number, then it's going to be negative infinity. So what I want you guys to get from the L'Hospital rule is that when we are at the end of the limit equation and we get 0 over 0 or infinity over infinity, and we can't use any of these tactics to solve it, then we must use it because it is a shortcut. But we can't use it all the time because abusing it would not help us learn derivatives at all. So I hope this video helped you guys out, and may the best of luck in your calculus future.